This is Steve Piloff from George Mason University. Sometimes when we have an annuity or annuity due, we know the present value of the cash flows, and then we know all the cash flows. We know what the amount of the regular cash flow is. We know how many they are. Since it's an annuity or annuity due, we know when they start. If there's any other cash flows, we know what those are. And what we want to figure out is at the end of the last period, the rate or the return of that annuity or annuity due, which is basically, given the cash flows that we know, given that we know the present value, what is the discount rate that makes those cash flows equal to the present value? Common examples: you borrow a certain amount, you have certain payments that you make at certain points in time. What's the interest rate on the loan, which is the discount rate that makes the present value of those loan payments equal to the amount of the loan? Or the return associated with an investment. You pay a certain amount to buy an investment, and then it pays you a certain amount of money for a certain period of time. The return is the discount rate such that the present value of those is equal to the price that you paid for it. And we're going to look at how the financial calculator can help us with that. So, as I said, you give it PV, which is the present value of the annuity or the annuity due. Suppose you have a case where you've got regular fixed cash flows. Give it PMT equals the amount of that. Put it in end mode so it knows that the first one's in one period. You tell it end so it knows how many there are, and if they start in time 1, the second's at 2, third's in 3, the nth is at time n. Give it FV. It's an extra cash flow not captured by these payments at time n. And then we'll solve for I%, which is the interest rate or the discount rate, such that the present value of all of these guys is consistent with the PV that we gave it. Begin mode is very similar, except now the n payments for in begin mode start right away at time 0. So at time 0 you got that payment, time 1, time 2, time 3. So it's the first payment, the second, the third, the fourth. The nth payment is at n-1. If there's an FV, which is an extra payment at time n, doesn't matter that we're in begin mode or end mode, give it PV and solve for the interest rate such that the present value of all this is consistent with that PV. So let's take a look at a few examples. You borrow $20,000, your monthly payment's $375. What's the monthly interest rate on the loan? Your first payment's due in a month, so in 1 month you pay $375. All payments for 5 years, so they're monthly, so you know that you have 60 payments. It didn't matter that it started in 1 month or whether it started today, you knew that there'd be 60 payments. The thing about the fact that it started in 1 month is now you know the second one, the third one, the fourth one, the fifth one, the sixth one, all the way out to the 60th one. And what we want to find is the rate such that negative 375 over 1 plus r plus negative 375 over 1 plus r squared plus negative 375 over 1 to the r plus third plus negative 375 over 1 plus r to the fourth, all the way out to negative 375 over 1 plus r to the 60th is equal to negative 20,000. So 60 payments of negative 375, or the cash flows are negative 375. The payment on the loan that we pay to the bank, 375, so it's negative. End mode, because the first one's due in 1 month. Present value of those is negative 20,000. Nothing extra at the end. And the interest rate is 0.39%. So if you discounted negative 375 in 1, 2, 3, 4, 5, 6, all the way up to 60 months, all 60 of those terms, added them up, you would get 20. If you did negative 375, you get negative 20,000. Borrow 20,000. Now you're making annual payments of $4,000. What's the annual rate? First payment's due today, and your last payment's due in 5 years, and all payments are equal. So these are annual payments, and we have our first in year 0 and our last in year 5. So we know that we have year 1, year 2, year 3, year 4, and year 5. We can count how many payments there are: 1, 2, 3, 4, 5, 6. So we want to find the rate. So it's at negative 4,000 plus negative 4,000 over 1 plus r plus negative 4,000 over 1 plus r squared plus negative 4,000 over 1 plus r to the third plus negative 4,000 over 1 plus r to the fourth plus negative 4,000 over 1 plus r to the fifth is equal to negative 20,000. And notice the last payment's due in 5 years, but n is actually equal to 6 because when we count the payments, the number of payments is 6. So 6 payments, start right away for $4,000. We pay them, that's why it's negative 4, nothing extra. Their present value is negative 20, and so what's the rate on this loan? It is 7.93% per year. Finally, you borrow $20,000, monthly payments $375. What's the monthly interest rate? Your first payment's due today. So your first is today, your second, your third, your fourth, your fifth, your sixth, your seventh. Your 60th is due in 59 months. Except there's an extra payment that you're going to make, $5,000 in 5 years. So again, in 5 years is in 60 months. So in 60 months, we're going to pay $5,000. So what we're really trying to find is the r such that negative 375 plus negative 375 over 1 plus r plus negative 375 over 1 plus r squared plus negative 375 over 1 plus r to the third all the way out to negative 3 plus negative 375 over 1 plus r to the 59th plus negative 5,000 over 1 plus r to the 60th is equal to negative 20,000. Let the calculator do a lot of the work. And in fact, this one's nice because we can do it in one step, because payments for 5 years is 5 times 12 means there's 60 of them. Payment in 5 years, and since our timeline is monthly because it asks for a monthly interest rate and we have monthly payments, it's also 5 times 12 is 60. We get to do it all in one step. N is 60. Present value is 20,000. Payments negative 375, meaning we're going to be making 60 payments of 375. We're in begin mode. They start today. That's what's going on here. And in addition, we've got an extra payment from us, negative sign, of 5,000 in 60 months, which is in 5 years. And so this line is consistent with all the information in the problem. And so the rate on our loan is 0.96% per month.